Hello students, previously we have done the topic kinetic energy and the potential energy. We have done both the derivation of the kinetic energy and the derivation of the potential energy. Now today we are doing the numerical based on the kinetic and the potential energy. Okay. Now we all know that the kinetic energy is the energy possessed due to the moving body, and the potential energy is the energy which the object possessed due to the position or the configuration. Okay. And we have derived the formula of the kinetic energy. What is the formula of kinetic energy? It is the half mv square. And what is the formula of the potential energy? It is m into g into h. Okay. So we are doing some question based on the kinetic and the potential energy. First question: what happens to the kinetic energy of the 25 joule? Okay, here the kinetic energy it is given 25 joule, and if the velocity it is 5 meter per second. Okay, the object it is traveling with the velocity 5 meter per second is doubled and tripled. Okay, so what you have to calculate? You have to calculate in both the case kinetic energy, but kinetic energy you have to calculate what will happen to the kinetic energy. Okay, when the velocity of 5 meter per second is doubled and tripled. Okay, now first thing we have to write the given condition here. Now what are the given conditions here? This is kinetic energy given 25 joule, velocity 5 meter per second is given, but our formula is half mv square. It means we don't have m. The first thing to calculate the kinetic energy is we require m. So this m can be calculated by using this relationship, kinetic energy equal to half and m into v square. Okay, so when you separate the m, you will be cross multiply. When you substitute the value first, kinetic energy it is given as 25, so you are writing 25. Half it is as it is. Since we don't have m, we want to calculate m, we'll write is at m, and v square, this is velocity, we have to write down 5 into 5. Okay, so on changing, the m will be here and you cross multiply, you will be getting 25 multiplied by 2, and this 5 into 5 it will go down. Okay, so when you will solve it, you will be getting this mass equal to 2 kg. Okay, now what is the next thing we have to do? The next thing we have to calculate this velocity when it is doubled and tripled. Okay, now we know that when this velocity get doubled, that 5 to the 10. Okay, so velocity now become, on doubling it will become 10. So or when you use the formula kinetic energy half mv square, you can write down half m we have calculated as 2. Okay, so we are writing 2 here, and v square, and we have to use the doubled velocity. And what is the double velocity? 5 to the 10. So we are writing 10 and 10. Okay, so this 2 and 2 will get cancelled off and you will get 100 joule. Okay, you will be getting answer 100 joule. Okay, now next we have to find out when the velocity is tripled. Now you can see here 5 was the velocity. When you do tripled means 5 into 3, you will be getting 15. So again we are writing the same formula for kinetic energy, half mv square. M we have calculated 2 kg. Velocity, now we have to take tripled velocity, it means we will write 15 into 15. Okay, so when you will solve it, this 2 and 2 will get cancelled off, and 15 square it is 225 joule. Okay, so like this you have to solve the question. Okay, now the next question, it is given certain force acting on a mass. Now this time the mass is given 20 kg, changes its velocity from 5 meter per second to 2 meter per second, and you have to calculate the work done. Now students, previously also I have explained, in the numerical it will not be mentioned that you have to calculate kinetic energy or the potential energy. Here simply it is written you have to calculate work done. Now such question if are coming, you have to identify the given conditions, like mass it is given as 20 kg, velocities are given. Now since the velocities are given and mass are given, and you have to calculate work done, now we can understand that when the velocities are given, it means it is the kinetic energy here we want to calculate. Okay, so you write the given condition, velocity changes from 5 meter per second to 2 meter per second. So from means this is the starting point. So you consider the initial velocity as the 5 meter per second and 22 meter per second. This is the final velocity. We will write 2 meter per second. Now there are two methods to solve. What is the formula of kinetic energy? Half mv square. Now either you calculate individually half mu square, because this is also a velocity. Okay, you can calculate individually half mvu square and half mv square, and then you can minus, you will get the same answer. But what we are doing here, we are taking half m as common, because again and again we do calculation, we can do easy in the common way. So 1 by 2 we are taking common, and bracket we are writing v square minus u square. Okay, so when you will put the values, you will get half into, now mass it is given as the 20 multiplied by, this is 5 square and 2 square. 5 square is 25, 2 square it is 4. So 25 minus 4 you will get 21. This 2 and this will get cancelled, you will get 10 here, and 21 multiplied by 10 you will get 210 joule. Okay, so like this you will be solving. And please remember that when the work done it is asked, and you have to identify whether it is velocity. If the mgh is given, it means you have to use mgh, but when the velocities are given, you have to use the kinetic energy formula. Okay, now here is the next question. A porter lifts a luggage of 15 kg from the ground and put on his head 1.5 meter above the ground. Simple, you have to calculate the work done. Now work done here is F into S. Now a porter lifts a luggage. Now what is the mass? Now you have to see in the relationship that the mass is given, but in this relationship the mass is not used. We have to calculate work done. Work done formula it is F into S. Now is the force given in the question? No. What is given? Mass is given. Now according to second law, we know that F is equivalent to m into g. So when you substitute the values, m it is 15, gravity we can take it as 10 meter per second square, and S is our displacement. So how much distance it is covering above the ground? 1.5. So we are writing here 1.5. Okay, so when this will get cancel off, the 15 square you will be getting 225 joule. Okay, so like this you have to solve the numerical, and before starting the numerical you should understand, write the given condition, which formula is to be used, and when two velocities are given like the initial velocity and the final velocity, you always have to use this formula of kinetic energy, half m v square minus u square, so that when you substitute the values you can easily get the answer.